All right, for question 29, we have an inequality, and on the left-hand side of the inequality, we have a rational function. So, well, we learned about rational function. We should know how to graph this rational equation. Okay, so let me go ahead and make a quick sketch of this. Now, in order to make a quick sketch, it will be a lot better if you have the factored form. And what you can see very easily is that the denominator could definitely be factored a little bit further to x plus 3 and then times x minus 3. So you have the whole fraction x plus 1 over x plus 3, x minus 3 is greater than or equal to 0. Now, when we look at a fraction, this is also the time that we start wondering what cannot be, what values x cannot be, what value or values that x cannot be. And why do we ask that question? Because when we have a fraction, there are some specific values that we don't want to see, such as 0 in the denominator. We don't want to see 0 in the denominator because that would cause the whole fraction, the whole function to become undefined. So now we need to investigate a little bit, which is like, yeah, what couldn't x be? And if you have a factored form, then you can make the conclusion very easily. You can say, well, x cannot be 3 and x cannot be -3. Because if x is either one of these two numbers, well, the denominator will become 0. That's bad. So we will have two vertical asymptotes. Now, and this is the part where I must give my warning. Okay, I must give my warning to students here that please do not reverse the procedure. Okay, do not memorize the steps without knowing the why. If you know the why and then you get the steps, then everything becomes very intuitive. But if you don't know the why, but just memorizing the steps, then you're just hurting yourself. You're wasting time, and it's not going to work well for you. Okay, so the reason why we have vertical asymptotes is because the function cannot be there. And for this particular function, well, x cannot be 3 and -3 because that would make the denominator 0. If you know the reason, the steps would come in naturally, and it makes perfect sense to have those steps. It makes perfect sense to say factor the denominator and set the denominator equal to 0. Now, those are the two vertical asymptotes. And now, do we have any horizontal asymptotes? Now, the horizontal asymptote is by thinking what would happen if x is going to infinity or -infinity? What would the function be? Okay, what would the function be in this case? So you just imagine, okay, the way I'm going to explain it is that imagine that x is going to become a gigantic number. X plus 1, well, if you have a gigantic number, would the +1 matter? And we would say, not really. Would the -9 matter if you have infinity square? Well, not really. So you can simply simplify so x minus 1 over x squared minus 9. So we say, well, the -1 doesn't really matter. The +1 doesn't really matter. -9 doesn't really matter. So you can reduce it down to x over x squared, which is 1 over x. And then you put the infinity into the x, and we ask, what is 1 over infinity? A very small number. So we say f of x is going to become, become 0 for both cases. F of x will become 0 for both cases because we have 1 over infinity or 1 over a -infinity. So we know the horizontal asymptote is going to be 0. Okay, so that's the horizontal asymptote. Now, will it would the function cut the horizontal asymptote? Because it could, but it's not all the time. It could. Well, let's go ahead and see if there's any x-intercept on this graph. Well, x-intercept, how do we find x-intercept? Well, x-intercept is where you have the x value and the y value, it's always 0. So basically, you are thinking about x plus 1 over x squared minus 9 is equal to 0. And for a fraction to equal to 0, for a fraction to equal to 0, well, the numerator must be 0. Okay, so you can think about it this way, or alternatively, you can think about, well, let's just go ahead and multiply x squared minus 9 both sides, and then you still have x plus 1 equal to 0. So x is equal to -1. So that means the graph actually does touch the horizontal asymptote because we have a x-intercept. We have an x-intercept at -1 comma 0. Do we have a y-intercept, we ask? Y-intercept is when x is equal to 0, and we found out the y value. And so we will go ahead and say, well, so y value is equal to 0 plus 1 over 0 squared minus 9. So we have 1 over -9. So -1/9. 1/9 would be the y-intercept. So that would be somewhere close to here. So with these 2 points, we could actually have a pretty decent idea on how to draw the middle part of the graph. The middle part of the graph, it's going to be like this. Okay, the middle part of the graph, it's going to be like this. Okay, now the question is, what happens to the other 2 sides of the graph, because we need them too. So would it be above the x-axis or below the x-axis? Okay, for the either ends of the graph. Okay. Okay, so how do we know the graphs on the other 2 sides? So we say, let's pick a number. Okay, what's easier than well? I think the easiest thing is to pick a number, and then you can tell whether it's on the positive side or the negative side. So pick a number that's less than -3. Okay, and we say, well, let's go ahead and try -5. Okay, you can pick any other number, but I'm going to pick -5. Okay, so we say -5 plus 1 over -5 squared minus 9. So I have -4 over 25 minus 9. It's 16, which is equal to -1/4. So it's going to be somewhere right here. Okay, so that tells you that we will have a graph that's below the x-axis. Okay, all right. And then we can do the same thing on the other end of the graph. We will say, well, okay, let's go ahead and pick a number that's greater than 3. And I'm going to pick 5 in this case. 5 plus 1, and then 5 squared minus 9. So I have 6 over 16, which is 3 over 8. So it's somewhere right here. Somewhere right here, approximately. So we have the graph being drawn like this. Now, keep in mind, the graph that you're drawing, that you're sketching must, well, it always is a reflection of the values of the function. If you are ever in doubt of anything, you can always substitute some x values, find out the y values, and then see if it works. So now we want the part that is greater than or equal to 0. So which part of the graph is greater than or equal to 0? So we say, well, this part right here is clearly above 0. So that looks very nice. And this part of the graph, it's also above 0. Okay, and also including this point right here, it's also it's at 0. So our solution is going to be from -3 to -1, inclusive, and since we will include the 0, union 3 to infinity. So this would be our solution right here. Okay, this would be our solution. This would be our solution. Okay, so yeah. So graphing, I believe it takes a little bit more time, but you have to graph it anyways. So practice makes perfect. So I would suggest you to get more proficient, more comfortable in making these rational equation graphs.